Hey everyone, and welcome to our first video in Unit 6 titled Factoring Polynomials by the Greatest Common Factor. Okay, so I really want you to pay attention to this word because this entire unit is about this thing called factoring. Okay, how do I describe factoring? Well, factoring is pretty much the reverse of everything you did in Unit 5. I think of Unit 5, like when you're multiplying polynomials together, you're sort of building them up. Factoring is the opposite of that. Factoring to me, now this is Callahan terms, factoring means to break down a polynomial. Now, right now that doesn't make much sense to you, the Callahan definition, but it will. You sort of take a polynomial and you break it down into parts, so to speak. So let's take a look at vocabulary for this lesson. It says, this is the fancy definition. A polynomial is factored or in factored form when it is expressed as a product of other polynomials. Okay? So anytime you take one polynomial and break it down into a product of other polynomials, you factored. And then I wrote here, factoring is the reverse process of multiplying polynomials. So there are different types of factoring depending on the way a polynomial is presented to you. But probably the most basic of all factoring is what we're going to do here. It's called factoring by the greatest common factor. And this is actually something you want to look for. I don't care how complicated your polynomial is, you always want to start factoring by looking for a GCF first. So this is like super, super important all the way through the unit. Okay, let's take a look at example 1. So it says factor 2x plus 2. Okay, seems easy enough. Now right now, this is a polynomial, okay? 2x plus 2 is a polynomial. Now if we want to get down and dirty and more specific, it's a binomial because it has two terms. 2x is the first term, 2 is the second term. It's got degree 1 because of course the exponent here on the x is 1. Okay, what we're going to do is break this down and express it as a product of other polynomials. And you do that by finding the GCF. So let's come off to the side and let's review GCF. Now my last lesson video was on GCF. So the greatest common factor, you can find it by hand by breaking down your terms into the prime factor. So if I take a 2x versus a 2, so I split up my two terms, here's the deal. 2 is already prime because it can only be expressed as 2 times 1. So that's done. They have a 2 in common. So 2 is part of my GCF. Now, I look at the x. This term has an x, this one does not. So they have no x in common, so I cannot include that in my GCF. Now, you're going to open up parentheses. And you're going to put the leftovers in the refrigerator. This is like the refrigerator here. How do you get the leftovers? Well, you take the original expression and you divide each term of the expression by whatever's out here as the GCF. Whatever the result is, you put here. So 2x divided by 2, well, these 2's will cancel, so you're just left with x. Bring down the plus sign. 2 divided by 2, 1. This is the final answer. This is the factored version of this polynomial. Now let's think about the definition. Is this a product? Sure. You're taking a 2 times a quantity, x plus 1. So there's your product of other polynomials. So you're multiplying a monomial to a binomial expressed as a product. This is the factored version. Okay, let's go to example 2. Factor 4x plus 12. So we got to find the GCF. So 4 and a 12. Now maybe on this one, you're going to go to your calculator. Who knows? Maybe you're going to press math, num, 9, 4, comma, 12, and see that the biggest number that goes into both 4 and 12 is 4. Bring it on out, GCF. X, nope, can't include an X because this has an X and this doesn't, nothing in common. So we open the fridge and we're ready to put the leftovers inside. Let's divide each term by the GCF of 4 and put the result right here. 4x divided by 4, boom, is just x, plus 12 divided by 4 is 3. Final answer. Now here's something cool. You can check your work. Think back to Unit 5. How do you multiply these two? How do you multiply this monomial to this binomial? Well, you distribute. 4 times x, 4x. 4 times 3, 12. Bada bing, bada boom. See how they're the same? That's how you know you did it correctly. Okay, example 3, we're cruising. By the GCF, factor 12x plus 18. Okay, again, no x on the 18, so let's just look at the 12 and the 18. What's the biggest number? What's the biggest number that divides into both 12 and 18? 6. You can use this if you need to. Don't forget, go back to my video on how to find a GCF. You can break these down to their prime factors. Circle what they have in common. It's going to be a 6. Okay, open the fridge. Divide by 6. Divide by 6. Okay, 12x divided by 6. Well, 12 divided by 6 is 2. So we've got 2x plus 18 divided by 6 is 3. Final answer. If you don't believe me, distribute. You're going to get right back where you started. Okay, example 4. A trinomial. Okay, it's still a polynomial, trinomial. So when we factor by the GCF, we just have to take 3 numbers into consideration here. Now, let's do this one longhand. Like, let's break this down. So because I haven't done one like that. So if you take a 3x squared, let's start with the first term, and you take it down to its prime factors. Well, 3 already is prime, so I would just write 3 times x times x. Okay, that's my first term written as a product of primes. Let's go to the middle, 18x. Well, 18 can be written as 9 times 2. 2 is prime. 9 is 3 times 3. They're both prime. So 18x, written as a product of prime factors, is 2 times 3 times 3 times x. There's that x. And last but not least, the third term here is 9. And 9 as primes is simply 3 times 3. So there you have it. So now you're looking at these 3 different terms. You're going to highlight or circle what's common. So they definitely have 1 3 in common. Now these two have another pair of 3s, but he doesn't, so you can't highlight another 3. Let's look at x's. There's some x's here, there's an x here, but there's nothing here. So altogether, they don't all have an x in common. So my GCF for this problem is just the number 3. Now I could have avoided all that and just said, hey, look, what's the biggest number that goes into 3, 18, and 9? And that's 3. I also could have used the TI. Now, if you remember from my LCM video, what happens when you have 3? Well, the calculator can't handle 3. So you have to do the wrong one. Math, num, 9. You can only do the first 2. So 3, 18. Now that gives you 3. Then you do it again, math, num, 9, with this answer and the last number, 9. And you see it's 3. So I've kind of confirmed that our GCF is 3 different ways here. I'm hoping it makes sense. Now open the fridge, make it a little bit bigger fridge because you got 3 terms now, and divide each term by the GCF. Okay, so 3x squared divided by 3 cross is x squared. Plus 18x divided by 3, that's 6x, because 3 goes into 18 6 times. And finally, 9 divided by 3 is 3, and that is the factored version, product of that polynomial. Okay, one more to go and we're done. Factor. And now we've got another trinomial with some k's in it. So let's grab the numerical part. Let's compare a 4 to an 18 to a 6. The biggest number that goes into 4, 18, and 6 would have to be 2. Double check me here if you want to. How many k's do they have in common? Well, this guy has 4, this guy has 3, and this guy has 2. So if you wrote them out, k times k, 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 you would only be able to circle 2 k's from each term in common. So let's do k squared. Remember, the shortcut is it's always the lowest amount in any one term. Open the refrigerator. Divide each term by the GCF. And then figure out those quotients. Okay, 4k to the 4th divided by 2k squared. Let's think of our quotient rule here. 2 goes into 4 twice, so I definitely have a 2. Now, what do we do with this? Do you remember the rule? When you have k to the 4th divided by k to the 2nd, you subtract the exponent. So 4 minus 2 is 2. Plus 18 divided by 2. 2 goes into 18 9 times, so 9. K to the 3rd divided by k to the 2nd. 3 minus 2 is 1, so k to the 1st. And then last but not least, 6 divided by 2 is 3. K squared over k squared, well, 2 minus 2 is 0. K to the 0 is 1. So 3 times 1 is just 3. You could also think of it as the k squareds just completely drop out, because let's not forget, even though like this is our final answer, for my writer outers, like say you were doing k to the 4th over k squared, you would do this. Cross out 2 with 2 and boom, you're left with 2. That's why that's k squared. This one, when you have a k times k over a k times k, they all drop, and we answer that with a 1. So 3 times 1 is 3. Okay, cool. So that is factoring by the GCF. Thanks for watching.